So we have a name. I'm at a point where I'm now comfortable releasing the software. It's open source. I've just opened up the repo to public. So if you want to have a play, you're most welcome to. Basically, this is a controller and interface designed for a Wally animatronic or potentially any other droid that just uses similar things like track control, maybe a NEMA 23 to move stuff, and maestros for controlling servo movement. The front end for this, I've designed it in two ways. It'll either be for a Steam Deck, which is what I primarily built it for and where I've got all the functionality working how I want. I've also built a web interface for it as well. And the web interface runs on a back end, which is running on a Raspberry Pi 5. A Raspberry Pi 4 may work. I have not tested it. There are some GPIO library differences between it. I think I've got backwards compatibility in it, but a 5 is definitely work for it. It certainly doesn't need all the compute of the 5, but it's just what I had round, so that's what I built it against. I've also built in Bluetooth controller support as well. So maybe you don't have a Steam Deck, but you got a Bluetooth controller and maybe an Android phone or an iPad, and you want to have that functionality where you've got a web interface as well as the controllers. You can absolutely do that. Should work for you. Talking through the screen, first call out is I'm running this on a MacBook at the moment just because it's easier to show you and screen record on it than it is directly on the Steam Deck. You may notice some things like the location of these top settings up here are slightly off center. That's because when it renders on the Steam Deck, it moves things through its scaling a little bit. So while it's off here, it looks perfectly correct on the Steam Deck. Down the bottom, we have a number of different navigation screens you can go through. There's a failsafe button to stop it at any time. Camera screen, it's got the ability to do motion tracking. So if you want to turn on tracking, it will look for motion such as hand waves, and it can trigger a hand wave back. So it'll do right hand wave, left hand wave, or both hands up in the air. It's got stand down. It's got other logic around checking to see that the person's not doing it repeatedly. So if you're in a con event and there's lots of people, you don't want it triggering all the time. We've got a telemetry screen, so battery, current consumption, memory, temperature, status of the different controllers, and the maestros are in there. The screen's around where you do the definition for the NEMA 23. So in my case, it's got a gantry, and I want to control the positions. It's basically a two toggle position of arm forward or back, and you want to define where that is and how fast the NEMA 23 moves and how far it goes. This is where you do that. The maestro controllers, I've got two maestros that are running on it, and depending on the number of channels, it will configure the screen based on that, and you can give them names. You can define the minimum and maximum positions. You can define the speed and acceleration on it. The speed and acceleration columns will update the maestro. The minimum and maximum positions, it won't update the maestro, but the code will leverage these values here. That's a limitation of the serial libraries that exist on the maestro. But my recommendation would be on the maestro, you set the minimum and maximum values to the upper movement range of how far you could do it before you'd be in a position of breaking it. And then on this screen, I would modify these based on the a lower range of where you would actually want the movement to be. So quite often you can extend it well beyond what would look realistic. This would be the realistic settings that you'd use. Controllers, so this is where you do your mapping between your controller buttons. What type of behavior? Is it a direct servo? Is it differential tracks? Is it just triggering a scene? You can define that in here, and each one has a configure button, so you can select the servo and the maestro channel, so you'd have like a list of all the different channels that are available for you. There is the status of your controller. In this case, I'm using a Bluetooth controller at the moment. A controller calibration, so this is where you can check your zero positions and define the outer extremities of each of your joystick movements. We have a setting screen, so you can set your debug levels for different parts of the code. You can even change things. So as mentioned, if you wanted to go between, say, Wally and maybe a Star Wars animatronic, you can hit that, and hey presto, we've now got like an R2-D2 based theme, for example. So a lot of the controls are the same, so I thought, why not have it themed? Lucky last is scenes. So this is where you define both categories and scenes. So I'll talk a little bit about that shortly. But in one of these cases, I have a scene category called frustrated gesture and a category called angry. I can choose where it has an audio track and what script to play on the Maestro. So it gives it an idea of what it needs to run with, and it will play that when you trigger that scene. So back on the home page, from here, navigation on this screen is using a D-pad on the controller, whether it be a Steam Deck or a Bluetooth controller. Across the top, your left and right navigation changes the categories, and you'll see underneath, depending on the category, you'll see that the scenes that are available have been defined here, and a scene can be a member of multiple categories. So it doesn't have to be a one-to-one, it can be a one-to-many relationship. So I could choose a category, let's say happy. I can then navigate up and down using the D-pad, and when I want to trigger one, in this case I might press the B button, and you'll see it's now fired off that event, and it's finished, and it's moved on to the next one. So by default it's set to sequential, so if you just keep on triggering, it will move on to the next one again in the list once it's finished. Or I can go random, and then once it's finished playing, it'll fire it back to a random one within that list. So it's gone up one in that case. I'll try out one more, see if it jumps. There we go, and it's jumped to the top in that case. I've also built in an idle function. So this is if you're at a con, for example, you want to have a bit of a break, but you don't want Wally to look completely inanimate. You can trigger this one here, and then every 30 seconds it will fire off an event from the idle list. So I have a category called idle. So these are different movements where maybe it's just a sound or a small movement like an inquisitive look or a head turn, but not arms flailing or anything that might potentially cause an issue where Wally could, like, you don't want tracks to be going and it fire off into a crowd, or arms hitting a child or something like that. So this is more head movement, eye focused, pan tilt type motions, just stuff to keep it kind of active and looking like it's alive. Cool. So that's the Steam Deck view. Let's go have a look at the web view. Okay, looking at the web interface, tried to make it a little bit stylish. Again, it should work. It doesn't have obviously some of the same Wally theming. I've tried to keep it fairly basic, but still make it look interesting. Again, across the top, we've got the different categories. This doesn't have the camera view in it. I didn't want to put that load onto the Raspberry Pi. I was leveraging the, I guess, the extra compute that I had on the Steam Deck controller for the motion detection piece, without impacting anything like the timing for a NEMA controller or a Maestro controller and servo control. So I wanted to give the resources that the Raspberry Pi had to running exactly what it did. Even though it doesn't need all of them, I just felt that I'd separate it that way, and then all of the front end had to do was just trigger a scene and it can focus on the scene. So again, you've got a very similar view here. So this is the scene and category screen. Again, you can navigate with the D-pad up down to navigate between them. There's a health screen still, so giving you a telemetry view of what's going on. Servo position screen, so your different Maestros, etc. are in here, and you can define those. NEMA 23, again, similar capabilities, so you can move it and it will move the NEMA 23 to those positions. It gives you like updates of what's going on. What else have we got? Controller. So at the moment it's showing you what type of controller I've got on there, status that it's connected up here, your mapping components of what goes to what channel, etc., all down here as well. And then your mapping editor is down the bottom, so slightly different look and feel, but it's designed more for a web page where you can scroll a whole lot more. I've got no idea what sizes people will have. It has been designed to be responsive, so it'll change the layout based on what your screen resolution is. Again, scenes, so this is where you can configure your different icons for it, your different categories that we talked about, whether or not you've got audio, what files are available for those, script, what script number, etc. And you can test and preview some of those. And then settings is fairly basic, so what your WebSocket backend is for it. So again, it tries to leverage the same capability as the Steam Deck front end. And a failsafe button again up the top right in this case. So yeah, that's the web interface for it. This would be the primary screen. I'd imagine that you would use the most, just picking your category and flipping between what you want to do, or leave it at all and work your way through the list. It's enough that someone else could use it. This wasn't my intention to build this, but when I kind of started out, I thought, well, why not? There might be other people that could leverage the code. Oh, one last one. In the settings, there's different themes again. So I could go Star Wars. It just changes the theme to a blue theme more than anything else. Everything else is still the same, but it's just the coloring on it. And then there was a modern one, which was just actually a slightly different color blue. But yeah, that gives you an idea of where that is at. So now let's talk about installation. There are 2 projects involved, and this will depend on whether or not you're going to go with a Steam Deck front end, the same as I'm doing myself, or whether you're just interested in the back end with a web view. So the Steam Deck one I've called Droid Deck GUI. That's the first repository that you'd want to check out. The second one is for the back end, and if it's just the web, is this one here. And this one's called Droid Deck Backend. First call out around the code that's in here. I do code. This was a bit of an experiment for me because I was playing around with vibe coding. So using the likes of GitHub Copilot, Copilot itself, and Claude. Mostly using Claude and the Sonnet 4.5 model. Found that to be the most robust between it. It still definitely has limitations, but this has really been an experiment going, how far can I go with vibe coding to build out an animatronic and a web interface with it? And the answer is quite far. It's not bad. There's definitely some limitations. There's a little bit where you'd have to do things, but this would mean that you don't need to be a developer to modify and change this code to something else. You could effectively drop this project into a project folder in Claude and run your own queries to go, hey, modify this, change it, add this functionality, move this here, and it will give you some pretty reasonable code. You may have to take a snippet, find out where it is in the code, copy paste it in. It does lose track if you have lots of files. Well, this one does have quite a few components to it, so it doesn't put it into its context window. And you make a change and then you suddenly lose a whole bunch of functionality. But if you start understanding the limitations, you could do this with not that much coding experience. I've used it extensively for things like documentation because I'm always really slack at documentation. So hopefully it's not too bad. I have tested some of the documentation steps to make sure it works, but buyer beware, it won't be 100%. That hasn't been the focus. My focus was for my own consumption. But then I thought, well, maybe other people might be interested in it. So let's talk about what's here. We'll start with back on the GUI one. So this is for the Steam Deck piece. So there are icons I've created specifically for it. So they're in this location here. So this is on the Steam Deck when you're in the game mode, that it actually looks like it's pretty decent looking. We have a installer file here. So this is the main one that configures everything for you, because effectively we want to create a container that we can put the libraries that we need in without impacting the base operating system, which is read-only. So we create effectively a container, we build the Python libraries, and we do all the installs within those libraries, and then leverage the audio controllers and the actual control itself from the Steam Deck, reading it from Pygame, and to be able to send that back to the front end. So we've got a little bit of a description around the components, the requirements on it, what libraries that we're using and how that works, and then the installation process. So it's not that hard. So you basically go to desktop mode, let it switch in there, you clone the repository across, and then you effectively have to modify it and install the script so it's executable. So you chmod plus x the install file, and then run the installer. That will take you 10 to 15 minutes while it goes and downloads all the libraries, installs the right version of Python and everything that we need, and that's it. Once you've done that, you copy across the files into the directory that's been created, so the Droid Deck directory, and then you can launch, and you're up and running. Now, that will work perfectly fine from the desktop mode. There's just another couple of steps in terms of being able to do that in the gaming mode. And then the gaming mode, it's just you select it from your library, and you run it from the library. So that would be my recommendation. Just do the extra steps. There's not a lot in that. That's actually more text information, just telling you how to actually add it and how to add the icons. So installation's relatively straightforward. It should work. I've tried to get the library versions of what I've used so that it will try and install exactly what we've got. And by doing it in a container, then we're not having to worry about the fact that when you update your Steam Deck that it doesn't blow away and corrupt the installation. So that should work for you. On the back end side of things, similar approach. This case, we mentioned Raspberry Pi 5. We've got some updates around what we've changed, hardware configuration, a little bit around, there's the TB6600, which is the controller for the NEMA 23. Your controller may differ, so just caveat that I'd have around those dip switch settings. So it depends on what your controller is. I did 1/4 micro stepping on mine because when I left it single step, it makes a bit of noise. Whereas under quarter step, it just sounds a whole lot smoother. So I set it to 1/4 micro stepping. You would have to change the parameters for the speed that it moves if you change it from anything other than that. So a bit of a balance between the noise volume, the accuracy of it, and how quickly it moves. A little bit around what pins on the Raspberry Pi to connect to different things, and how to connect all that up, what power supply, etc. In my case, I wasn't using 24 volts, I was just using 12 volts in this case. In the device I'm building, it's going to be about 14-ish volts will be the right area. I'm using a 4S LiPo configuration. Again, some of the default configuration here, how it's built, what the different files do and their purpose, the config files. I'll include the config from what I have on my own, so it should work relatively out of the box. And then we get to the install. So first part, we need to go through and update the interfaces. So you sudo raspberry config. We need to enable the SSH, the SPI, and the I2C components. Finish, get out of there. Update and install Git, and then it's a Git repository clone. Bring that down. Again, you need to change the install.sh file, so the shell script, to be executable. Execute the installer. And that will pull down all the libraries that you need and install everything that you want. It will set up a Samba share so that you can copy other files across, like audio files or other things that you want. You probably want your shell enabled as well, so you can remote into it. And then to start the system is Droid Deck. So it will configure and modify that one so it's executable. So in theory, within about 10 minutes from where to go was how long it kind of took me last time. That should get you your backend, including the web interface, up and running. Now, from there, there's other steps that you need to do. One is your Bluetooth controller. If you're using a Bluetooth controller, is setting it up and pairing that up and then configuring it. So that will be a little bit of work, and we'll talk about that one. And then the other call out, at the moment, I'm not running this as a service. I'm connecting to my home Wi-Fi network at this point. So that's currently a limitation. So at a future state, I will change it and I will set it up as a Wi-Fi hotspot itself. I will be using an external Wi-Fi device with an external high gain antenna. I don't think the Wi-Fi built into Raspberry Pi is going to be anywhere near good enough for a decent connection in an environment that's busy with other signals like at a convention. So I'll be using an external connection, and for Bluetooth as well, also an external connection as well. So I use a class 1 Bluetooth USB device. And the reason for the class 1 is distance. You can go a lot further with a class 1 device than the built-in Bluetooth. Otherwise, you may find in a noisy environment, you may only get a few feet before your connectivity's gone. So that's probably two call-outs. Is I will be using external USB devices, and I'll have them located in different parts to try and minimize some of the interference between the two on the Wally electronics itself. But that would be my recommendation, is you don't rely on the inbuilt Bluetooth and Wi-Fi. You'll probably want to run this as a service as well. So currently I will come in via shell. I will then start up the Droid Deck process and it runs. But in a con environment, you just want it to start on boot. So create it as a service with the ability to start and stop it would be my recommendation. But otherwise, then once you've paired your Bluetooth controller up, you just turn your Bluetooth controller on and it should auto pair and be up and running. Bluetooth controller setup, I have got instructions around that. It can be a pain in the butt, is probably my call out. But it talks you through what to do. Bluetooth CTL, scan on. You need to find the MAC address of it. That's the first one, trying to figure out which one in the noise of which one is it. With any luck, it will have some identifier come up to let you know it's your controller that's there. Then pair, and then trust, and then connect. Then you can exit out of it, and from then you should be able to connect up quite happily. You may then have to go look at your controller mapping so that like your X button may be currently mapped to something else in mind because your controller will be different. But I just had a cheap $20, well, New Zealand dollar that is, so even cheaper than in the US, controller I got from the local like equivalent of Walmart, and that just worked fine for me. Those are probably the main call-outs. So let's go back to having a look at what it looks like on the Steam Deck so you can see the controller in action. Here we have Droid Deck now running on the Steam Deck controller. So lovely little cover art, AI generated of course. We can select that, we can hit play. This will start up the interface on the Steam Deck. Takes 20-25 seconds or so roughly to load. There's got obviously a bunch of modules it needs to pull together for the different scenes and screens and backend. The sounds for both startup and shutdown I'm going to change, they're a bit harsh. Yeah, so that one's going to go. Just need to look around and look for some more public domain freebie ones which are available for general use, and we'll get them changed out. Critical alert there is because I don't have the full voltage running through the back end. I just wanted to have something to be able to measure a voltage and show a live reading. So that's why it's doing that. It does check to see what voltage range of the battery that's connected to it. And then it tries to determine whether it's like a 12 volt battery or a 3S or a 4S LiPo, up to 24 volts in total. So it's designed for that kind of range. As before, D-pad control to move between the different scene selections. Again, just choose between the categories down here. Sorry, categories at the top, scenes at the bottom. And then to trigger it, I'm just using the A button. That'll fire it off. At the moment it was set to sequential, so it'll just move on down to the next one. Everything else is pretty much the same as before, so fail safe, etc. You'll see that the heading is now in the right place, so even on the MacBook where it shows it's off, once it's rendered on here it does move things a little bit, but that's good enough for now. And we'll show you the camera component, so you might get some silence for a little while I run to the other room, but I'll show you from the camera piece here. If we start that stream, and we turn track person on, when I'm in there I'll do a wave and do a hands above head so you can see it doing its detection and triggering a back-end event. That worked.